Recording. There we go. And I'm going to introduce Joe, who's providing a presentation on Can Systems Thinking Improve Your Sex Life? We can discuss it afterwards because I don't want to discuss it before. So here we go. If I figure out how to do this, see, share screen.
Hello. It made it.
Go, and there we go.
Thank you for taking the time to watch this presentation on Can Systems Thinking Improve Your Sex Life? And the answer to the question is, it depends. And now let's talk about what it depends on. This presentation is going to remind you of the holistic thinking perspectives and active brainstorming because they're the tools we're going to use. I'll give a definition of the problem and the issues and the factors affecting the solution, and then we'll deal with defining your particular problem. And I'm going to introduce a new tool called the Problem Formulation Template. Then we'll discuss creating the remedy or the solution. A quick reminder about the 9 holistic thinking perspectives: big picture, operational, functional, structural, generic, continuum, temporal, quantitative, and scientific, and an example of how they can be used to deal with this particular problem. And again, active brainstorming, because we're going to use the Active Brainstorming Matrix to try and collect information that is pertinent to dealing with the issues. When we look at the situation from the big picture, we can ask questions like, what's the current baseline situation? What's the environment and context? What are the assumptions? What's the type of problem? Is it a system problem? If so, what's the system? What are the subsystems? Is it an interface problem? If it's an interface problem, what are the type of interfaces? From the operational perspective, we can ask some other questions. What are the operational scenarios? What are the maintenance scenarios? Is it working? Does it need to be changed? Well, in this case it does, because you want to improve it. Who's involved? Who benefits from it? Has the performance changed over time? What is the desired performance? From the functional perspective, how about questions like this? What functions are performed? When are they performed? Where are they performed? Why are they performed? How are they performed? From the structural perspective, we have questions like, what are the physical components? Are they reliable? Are they robust? Which components wear out over time? Are they maintainable? What are their attributes and properties? What are the maintenance scenarios? What tools are needed to enhance performance? From the generic perspective, we have questions like, what is this similar to? Who else has or had the same problem? When did it happen? What did they do about it? How are the situations similar? What can I learn from their experience? From the continuum perspective, we would ask the same question, who else had or had the same question? But now we're looking for differences. So questions like, what are the differences? What did they do about it? How are the situations different? What can I learn from their experience? From the temporal perspective, questions might be, what relevant past experience is needed to tackle this problem? Where can I get that information if I don't have it? The quantitative perspective deals with numbers. So, how often does the system have to operate? How often does the system actually operate? What are the desired measures of performance? How does the system actually perform? What are the costs of operating the system? Can the cost be changed? What's the baseline performance? What is the desired performance? We might add other questions like reliability. What's the reliability? What are the numbers associated with the functions? For those of you into system and software development, remember requirements can be considered as functions with numbers. As far as the scientific perspective is concerned, it really depends on the type of problem, and only you know that. The questions that I've given you so far are not the only questions. They're a set of questions. I'm sure you can think up your own to add to them. Is it a system problem? If it's a system problem, what's the system of interest? What are the subsystems? If it's an interface problem, what type of interface? Depends on the baseline. Everybody will start from a different baseline. It depends on whether you're going to choose to model your solution or prototype it. You might get to a different solution if you model or if you prototype. In this case, prototyping might be more fun. Asking all those questions and examining the answers and doing some research to find information we didn't know during the active brainstorming, we end up with a current situation. We have a list of attributes and properties, and for the sake of example, I've just thrown 3. The attribute is the length of the session, and the property is T minutes. The location desirability is X, and the cost is C. You have to fit in your own numbers. We've conceptualized a solution, so we now have the attributes of the solution. So the length of session is going to increase by little t minutes. We're going to increase the location desirability by 50%. And I guess you're all cheap, so you want a 50% reduction in cost. This gives us an undesirable situation, which is the need to transition from the current situation to the FCFDS. But at the moment, let's take a break and talk about system optimization alternatives. Are we going to optimize quality or quantity? In which case we have to define quality and quantity in numeric terms. Are we going to optimize the subsystem for partner 1 experience or partner 2 experience? Or are we going to optimize the system for mutual experience? I'm now going to introduce the Problem Formulation Template. It's a 5-part template. It starts with the undesirable situation as perceived from the HTPs, the objects and the relationships between them, and you've already done that if you've done the active brainstorming so far. Then you list the assumptions. It's extremely important to list assumptions because assumptions can mess it up, and you may assume something is wrong, or you may not know something. And if you give your list of assumptions to a subject matter expert, they can help you out and stop you going off in the wrong direction. At this point, you visualize the feasible, conceptual, future desirable situation, possibly known as the outcome, also as perceived from the holistic thinking perspectives. Then we need the problem. The problem is what needs to be done to convert the FCFDS to reality in reverse order. That is, working back from the answer and visualizing how we got there. And then we look at the planned solution, which is how. The problem is stated in terms of what needs to be done. The solution, the planned solution, is stated in terms of how the undesirable situation will be remedied in forward order. It has to be interoperable with evolving adjacent systems over the operational life of the solution and the adjacent systems, and it's made up of 2 interdependent parts. The transition process, which is often described in the form of a flowchart or a Gantt chart by project management, and the solution system, operating in the context of the desirable situation. So now let's look at our formulated problem. The undesirable situation are the unsatisfactory properties of the attributes. Our system has undesirable attributes. It's not fast enough, it doesn't last long enough, it's too expensive, or whatever. And in this case, it's the need to improve your sex life. And that means the need to improve the system. The assumptions are whatever you make about your situation. I can't tell you what they are because I haven't talked to you. I'm not in the habit of giving people solutions to problems that are totally unknown. Then we get into the FCFDS, and these are the new properties of the attributes as perceived from the HTPs. And in this case, it's a conceptual vision of the system operating as desired. Might be wishful thinking at this time, but we'll find out. And then there's the problem. Now let's just assume we've got 100 activities, because I don't have space for 100 here. I'm not going to work through it for you. So the 100 is the FCFDS, which is enjoying an improved sex life, or you can think of it as the system operating as desired. We now work back from the answer, so we have to figure out what were the immediate step we did before enjoying the improved sex life. What did we do? We did something. And what did we do just before that? And what did we do just before that? And what did we do just before that? And so we get down, going all the way through to research unknown information. But before we researched unknown information, we performed active brainstorming to find out what we knew and what we didn't know. Well, before we could perform active brainstorming, we had to arrange for the active brainstorming to take place. And before we could arrange for the active brainstorming to take place, we had to be in that current undesirable situation. And those are the first 4 parts of the Problem Formulation Template. And that really helps with planning any type of project. I talked about forward backwards. We plan what needs to be done working backwards from the target to the shooter. We work backwards from the FCFDS to the undesirable situation. And if I want to talk about it in terms of systems engineering or creating a system, before the system is working, it would have to be integrated and tested. Before it's integrated and tested, the subsystem components would have to be tested. Before they're tested, it would have to be built. Before it's built, it would have to be designed. Before it's designed, it would have to be specified. So you can see we're working back from the solution in terms of what needs to be done. And then we document how to do it, or the process, as a forward-looking plan. And this is how we create project plans. So we could show that process as a Gantt chart, like this. It's commonly known as a waterfall view, but it's really a Gantt chart. Think about it. If you moved those design, build, test into a vertical column and just filled in the blocks, you'd have a Gantt chart. If you know what an n-squared chart is, or a structured design matrix, you'd see it right there. And if you're familiar with a waterfall view, it's exactly the same thing with the back end turned up. Do you know that we have educated 2 generations of systems engineers who don't realize that the V view is the waterfall with the back end turned up? They think it's something new. When we're looking at solutions, we've got to realize the difference between systems thinking and non-systems thinking. In non-systems thinking, there's generally a single correct answer, just like in mathematics. 1 and 1 always equals 2. and the remaining answers are wrong or incorrect. But in systems thinking, it's different, except in mathematics. They're acceptable solutions. They're feasible solutions. They're optimal solutions, and they're unacceptable solutions. And we can arrange them in a continuum like this. So unacceptable solutions could be infeasible or feasible. They could be feasible, but they're unacceptable for some other reason. Acceptable solutions are always feasible. Optimal solutions are feasible. And I suppose you could have an acceptable, infeasible solution, but it wouldn't work. So maybe I should change this to the range of potential working solutions. But it gives you something to think about. Now, creating the solution is a research issue. You've used active brainstorming, you've researched the unanswered questions, so what are you going to do? Well, you use some generic thinking to think about possible solutions. You can do a literature review of the domain and access lessons learned by others. There's a lot of stuff out there that will help you if you know where to look. You can do this yourself. You can hire a consultant. Go talk to a therapist. And this is an often neglected but critical step in the current process. So you gain an understanding of the situation. You do some prototyping or modeling. If there are interface issues, you deal with them. You start with cause and effect, and you consider time delays. And this leads you to causal loops. The traditional way we show causal loops, as I showed you in session 1, were negative loops and positive loops. But you may want to consider the time delays in the loops so that they're iterative. You may have one run of the process and learn something from it, so you improve in the next run of the process. And when we do this in computer software, we call this upgrading the system. But when you're dealing with your sex life, you can learn from each session and improve the session. You don't have to improve it the first time. Well, you should improve it the first time, but you don't have to get all that improvement in the first line. Prototyping, trial and error, that's the fun part. So in summary, what I've talked about in this session were a reminder of the holistic thinking perspectives and active brainstorming, discussed defining the problem and the issues and the factors affecting the solution. We defined the specific problem. I gave you the problem formulation template, and then I talked about creating the remedy or the solution. How you do it, that's up to you. I'll now turn the session back to the moderator to handle questions and comments. Thank you for listening.
Let's see. Where'd it go? There it is. Ah, okay. Hello, everyone. Thank you, Joe. Interesting. Does anyone have a question or comment?
I saw some comments in the chat.
Yeah, unfortunately, I don't think many of them were directly attached to the presentation, though I might be able to bring them all together. So as much as I like sex, watching this and some of the previous presentations and reading some of your writings, Joe, I wonder why, or if, maybe if is a better way of stating it, that there appears to be a baseline, maybe even a framework for what the way of going about observing, characterizing, and solving systems level issues is. And it would appear to me that there is probably some consolidating factors associated with that. Have you or anyone else that is involved, because we have some experience with us, has anyone seen a correlation between the various methods that have been suggested for doing this and a comparison about those and seeing whether there are areas of similarity that could be consolidated? Sorry, I didn't mean to ask a simple question.
That's all right. You use so many big words. I'm trying to figure out what they mean, and I lost the
Sorry.
track of the question. I lost. The
Well,
track.
again, it's really if we were to somehow take a look at the processes, methods, and tools that are suggested as ways of solving systems problems, they tend to align within a discipline of systems engineering activities. And while there are some standards, not everybody follows them. And people think that what they do is better than what other people do. But it would appear that systems engineering, one of the kinds of jobs that it does is it takes a confusing mass of information and tries to find some way of making sense out of it. I haven't actually seen that happening as of yet. I think about it on and off, but I haven't figured out how to get started with it on my own. And I'm not sure that it's a job that one person can do.
Well, in the real world, you don't have that luxury, because you can argue that if you use certain approaches, you will get to the solution, and if you use other solutions, you can predict failure, and then you have to spend money and time to allow that project to fail. So you can't do this test in the real world. You can do it in academia, where you could set up project teams or student project teams to work through a particular methodology and see what happens and guide them through it. And you could use something like Gene, I think Gene talked about Michael Jackson's a methodology for, a system of system tools. That was the first mention of the word system of systems, where he discussed the different methodologies and approaches. And basically, though, as Jim pointed out, they're really all the same thing. Different ways of thinking about the relationships and understanding the situation. So I'm not sure that all these methodologies are really any different. They were just invented by different people in different places using different terminology. And that was one of the things I found when I started looking across disciplines to see what was being done. For example, when I was in Singapore, I was asked if I could put together a course on improving policymakers, in improving the decision-making process for policymakers. And I said, sure, no problem, just give me 6 months notice and I'll do it. So then I went out, and so a few months later, they came back and said, we've sold this course, you have to deliver it on this date. So I said, fine. And then I went out and started doing some research in the library and on the internet. And I found that there was hardly anything written on it. So I couldn't do my usual course development by looking at the literature, merging it with experience, doing some benchmarking of what other people are teaching on the subject, and then creating the course. So I had to sort of work it through. I had to sort of understand the problem that policymakers were facing, and the situations that they used, and I found out all sorts of interesting things, and I found out why policies fail more often than not, and I put together the course. And basically, I found that when you write a policy, you have exactly the same issues as when you're writing requirements. The policy has to be clear, concise, specific, measurable, testable, and so on. And so the types of problems people are facing are I won't say they're exactly the same, but the pattern is there,
right,
irrespective of the methodology. So when I come in and do. And so I would argue that in Derek Hitchens' 5 layers of systems of complexity, systems engineering is down at level 2, down in layer 2. Policy making is what we call systems engineering in layer 5, except they call it politics, or they don't call it systems engineering.
Okay.
And now I've forgotten the rest of what I was going to say because
Well,
your
no,
question
well, yeah, no, but I think you're surely down an interesting trail with that, and it strangely enough does tie back to part of the discussion that was going on in the chat, which is the proposal by Pascal that everyone is a systems engineer, and while I don't like that terminology, I would suggest that everyone is a problem solver. And some of them use systems engineering techniques or systems thinking techniques. And I guess that may be where I'm actually driving to is there are a core set of techniques that we can ascribe to a way of human thinking that are underlying all these different attempts to solve problems. So
Well,
that's the kind of question I'm sort of poking at. Not really sure of exactly how to get it in the heart.
well, if I were to put together a pie chart of types of thinking of people, I would say 80% of the people don't think. The next 15% think linearly, and there's only 5% or so who actually use systems thinking.
Go ahead, Pascal.
Yes, I said everyone is a systems practitioner. You have, like Prof will call them, outstanding system practitioner. You have the great one, you have the good one, but you find a lot of natural system practitioners. Randomly, occasionally, when they wake up on the right side of the bed, they think straight, they solve systemic problem at a lower level, etc., etc. So it's more the extent of application and the quality of application that makes the difference. But I suppose Prof is a bit extreme when he says 80% of people don't think. They do think, possibly they think wrong, but they still do think.
I bet they love it when you tell them that.
Is it not
That doesn't-
just that we do,
that-
that they just think and we don't know? I mean, there are so many billion people on this world, on this earth, and we only see a few. So
Right.
that's just a sample. How about all the other people? A lot of them are thinking, and
Yes.
isn't the so-called system engineering approach or the system thinking stuff, isn't that those parts that we recognized as working
Yeah, useful.
and then collected and then say, now people have to do it, where a lot of people are already doing it?
Yeah, some people do it, like I said, haphazardly, randomly, and so on. And in fact, when I looked at the presentation, it gives me the impression that it's a holistic framework that brings together a number of good things that were done, that is still being done, again, randomly, haphazardly, here and there. So the beauty and the goodness of this framework is to bring all that together in a very structured, methodic, and holistic way. That's what I like about the presentation.
And isn't it a little bit, the word doesn't come in my mind, that we, of course, we know it all, and they have to learn.
I
Right.
don't think so. Some people do this naturally. They do part of this, not in this structured and methodic way, but they do bits of this naturally.
Well, now you're going into nature and nurture. Some people are born with it, and some people. So you can think of a continuum. The level of
Exactly.
skills you're born with and people are born at different points on that continuum, and then they can move up the continuum by education and experience.
Yes,
And so
that's
then
how I
you
see it.
and then now you go into a totally different domain. Bruce, I like your comment here. I know that I don't know nothing, just not enough. That's a double negative, which is a positive.
He tried to sneak that in.
Yeah. Well, you remember the comment about when I was a teenager, I thought my parents didn't know anything, and by the time I got into my 20s, I realized they must have learned an awful lot in those few years.
So-
If we go back, there are some general principles that have been shown to provide successful solutions to complex problems. And yet there are an awful lot of people who ignore them and think up new ones. And it's not only in our field, we've seen that in education over the last 50 years. People have thrown away techniques and tools that have worked for hundreds of years in favor of some new conceptual solution that didn't work and had to be changed back. And in the meantime, a whole generation of children suffered and will continue to suffer throughout their lives because of what they learned that was wrong and what they didn't learn that they should have learned. And yet we continue to do this. There's something wrong in society. And part of it, I think, is people don't think through the consequences. Either because,
Lack of system thinking.
well, maybe it's lack of imagination, because it's very easy to see what there is. But have you seen people, they walk into a situation and they look around for a minute and they say, well, you need to change, if you change that, it would be really good and it would improve things. And if you change that, it would improve things. You change that, it would improve things. They have the ability to see double. They can see things as they are, and they can see things as they might be. And I noticed this, or at least I thought about it, what I was doing when I walked into a lecture theater in the university and I said, that clock's in the wrong place. Because the clock was behind the podium where the students could see it, so they knew how long they had to suffer through the lecture. But it wouldn't tell the
lecturer will not see it.
And the lecturer can't see it, so he doesn't know how to time his talk. So I can't remember how many times I had to take my watch off and put it on the podium so I could pace the presentation. And this is a simple example. But everybody is in situations where you bring in the right seventh man, and that person can point out things to you that you would never have thought of. And I've done it. I've gone into projects in trouble and I said, let me ask you a stupid question. Why are you doing that? And sometimes I know the answer and sometimes I don't. And they think it through and they realize, wait a minute, why are we doing that? We've always done it that way, but we don't know why we're doing it. Or nobody here knows. So they have to do some research to find out that it's there because something happened 60 years ago. And the command not to do it was never offered, was never given, or the reason for it went away, but nobody felt they had the authority to change it.
That goes back to my loop that I drew yesterday, or showed you yesterday.
Yep.
Bill,
So
I hear a lot of they. Yeah, they do this wrong, they do that wrong. Who do we think we are that we can judge that?
Well, I know who I am, and everybody else is they.
I know. I've heard that.
No, but seriously, it's a way it's a word that we use to define an unknown group.
Well, I suppose you have some unknown group in mind there.
No,
Otherwise, why complain that they are doing things not as you think it should?
first of all, I don't think my continuum perspective makes me recognize that the way I think it should be done may not necessarily be correct.
Okay, thank you.
But I know it's worked for me so far. Could a different approach have worked better? Perhaps.
But maybe you did it already for 40 years and don't remember why you decided to do it that way.
I went back actually and thought about some of the stuff that I've been doing and how and why. And I think it started when I was in kindergarten or primary school, when I had a teacher who kept saying, question everything.
Okay.
And he said that.
Did you make them suffer?
No, because by the time I absorbed that lesson and started to think about it, I'd graduated and was in a different school. But in order to question everything, what he didn't tell us was we had to think about everything so we can come up with the questions to ask. And then I got to the point where I started asking questions and got myself into trouble. Because people don't like their beliefs to be questioned. They don't like to be asked, why are they doing it? They just like to do it and don't think about it. And
that was when I asked the geography teacher, all these carbon stuff put in the earth for millions of years, and now we are taking it all out. Isn't there a risk? That was a stupid question.
Yeah. Risk to who?
In terms of
6 years ago, yeah?
Right. The Earth will be just fine. It will go on and on for another billion years.
I know. It will just keep turning without us, maybe.
See, I sort of explain something like that with, I draw, on the whiteboard, I draw 2 points and I ask students to come up and draw a line between them. And the ones that are not used to me will draw a straight line between them. The ones that are used to me will draw a wiggly line between them. And because when you draw a line between the 2 points, you're making an assumption that there's a relationship between the 2 points.
No, they just did what you said.
Draw a line.
No, there is a relationship once you put the line in.
Right. The line shows the relationship. And then I sort of tell them, now project, and I go back to the linear line, and then I say, well, now project that line forward. And then they actually stop and think, what basis do I have for projecting that line forward?
Let alone exponentially.
And the basis is what's happened in the past. And you see, and I started thinking about applying systems thinking to the stock market. And actually, and sort of looking at technical analysis, and that's what all the assumptions behind trends are. That it's been, the trend says it's going this way, it's going this way, it's going this way. Therefore, we can expect it to keep going that way. And it works for a while, and then it doesn't work. And so so we make decisions based on the assumption that the trend will continue. We don't think about tipping points. We don't think about all these other issues until we've experienced them once. It's like in America, in America, when the settlers moved west and they settled on the floodplains because they didn't realize they were on a floodplain. And then along comes the flood, and all of a sudden the houses are flooded and they start complaining about it. And you get the 10-year flood and the 100-year flood. And the problem is, the only real solution is move those houses out of the floodplain instead of spending lots and lots of money trying to protect them against a natural disaster that's predictable.
Yep.
But some of those solutions are not politically correct. They're not acceptable.
Mhm.
And when you ask good questions as a result of thinking, you suffer. And so you start keeping quiet. Like I suggested yesterday, ask your clergyman how many commandments there are in the 10 Commandments. Or an even better one. One of the 10 Commandments is thou shalt not work on the Sabbath. Ask your clergyman why he's allowed to work on the Sabbath.
It's not
Probably
working.
he
It's
thinks it's not
ministering to you.
working.
And you will be
It's ministering
excommunicated.
to you.
But if we come back to the theme of the talk, there are a lot of common factors, templates or patterns in dealing with problems. And whether the problem is improving something or creating something new, it's a different baseline.
Mhm.
But the steps you go through in a systemic and systematic manner are the same. And whether you call it, and I've noticed that in the Nkosi systems environment, if a problem is small, we call it we use the problem solving process. If the problem is complex, we use the system development process. But the steps conceptually are exactly the same. And many people don't realize that you don't start with a problem. As somebody named Sean spoke, somebody has to define the problem. And in school, we don't teach students to define the problem. We say, the teacher says, here's the problem, now go give me the solution.
Mhm.
But when you're out in the real world, the higher you get in the organization, the more vagueness you have to deal with, and you have to define the right problem. You have to define the problem and define the right problem. And that's what that problem formulation template is supposed to do. It's to help you think through the whole planning process of figuring out, describe the undesirable situation, then you figure out what the root cause, and you figure out what you need to do to overcome the problem. And you often, in a complex situation, you've got different stakeholders who can't decide on the cause of the problem, sometimes because they're only seeing it from their perspective, and other times because they're only looking from one perspective and there are multiple causes, like traffic congestion. But what you can generally do is so if you can't get consensus on the cause, you can get consensus on the solution. Because the solution is the current situation without the undesirability and perhaps some improvements.
Doesn't that also describe the problem?
Which meaning of the word problem are you using?
Well, if there is something, if there is a undesirable situation, and you want to subtract out the desirable situation from it, what's left is the problem, so to speak.
What's left is design the transition process from the undesirable situation to the desirability, to the desirable situation.
That's the solution. That's the solution, not the definition of what the problem is.
the definition of the problem is to figure out how to get
That is
from the,
one problem.
And so
I'll go with you on that.
so the problem solving process goes problem solution, problem solution, problem solution, what to how to what to how.
Mhm.
So the first problem is, or problem, the word problem can mean undesirable situation, the need to do something about it, or let's just go with those two meanings of the word.
Mhm.
You start with you have a vision of an undesirable situation. You have a vision that everybody agrees upon is the desirable future situation. And so now you're faced with the problem of designing the transition. So you figure out what needs to be done working backwards. So the next problem is to work out the how. How are you going to do it? So in our case of researching things that we don't know, that's the what. How are you going to research it? Are you going to do it yourself? Are you going to task people to do it? Are you going to bring in a consultant? And it depends on the situation and the complexity and the amount of things, the time you have, the budget you have, and the amount of knowledge you need to discover. But in each stage, that what has a number of different hows, and you have to pick the same one. So you're going through the decision-making process or the problem-solving process. They're pretty much the same thing, except they were named from different perspectives.
I'll disagree with that, and you'll see why in my presentation tomorrow.
Yep, and I can ask you, I'm thinking up some good questions to ask you tomorrow. Remember, you're presenting second. Would anybody else like to comment?
Come on in.
Yeah, I have a thought. So long ago, I realized that the way that I asked why more often than not made people defensive. So I stopped. And the realization came to me while watching Columbo. Remember Columbo?
I do.
The
Yeah.
1970s detective? Columbo had this method of self-discounting himself and trying to get other people to help him understand things that he found confusing, so that he would, actually discount himself to other people so that it sort of dissolved their defensiveness because of the way that he approached it. And I wrote this short paper called Change Management, the Columbo Approach, which is like a page and a half long. I can't write more than a page and a half because I lose focus. So, and it continually seems to work amazingly well so that people don't feel like they're being interrogated because you're asking them, why are you doing this? All right. You ask them questions and you look and you watch and you claim that you are confused and don't understand. And can you help me understand how it is that this is unfolding in this manner, as opposed to why are you doing this?
Is that where I got it from? Because I do that. I'm saying, I'm sorry, I don't understand. I mean, I'm sorry, I don't understand this. Why is it happening?
So it's the way you say it.
And
it's very important.
And yeah, and maybe let me ask you a stupid question. Why? It's not why. Why are you doing this? That will not get you anywhere.
And you know how Columbo came to his interesting questions. He got them from the door, because the question always comes when he's almost going out of the door.
There's just
So
one
he
more
holds on
thing,
the
right?
door and gets inspiration.
He's
Yeah.
as bad as Steve Jobs.
That little as the meeting ends, the detective says, "Oh, by the way," and then he asks, the key question. Oh yeah. But one of the things we don't teach in school is behavior, how to deal with people. And that's a very large gap in our education system.
Unless you have been educated in the Montessori way.
And when I wrote my book on project management, I went from the triple constraints to the quadruple constraints. Because
make it simpler.
I put people right in the middle of that triangle. Because it's the people that screw it up or make it work.
Mhm.
And people.
Yeah, but the triangle is a fallacy because better quality costs less.
Well,
we've been talking all day about that.
That too. But the three do affect each other, and yet they affect each other through the people that are doing the project.
Of course, without people, there is no project.
Exactly.
Right.
Without
So it could be a correlation, but is it a causation? The eternal question.
It's like a hypothesis. You can never prove a hypothesis.
Yep.
Right.
Last chance for more comments synchronously. Okay, Bruce, we're done.
Well, then it might be time to turn this back over to the host as compared to the moderator or the chair.
Yes, the moderator, why don't you stand up and show us the session chair you're sitting on?
The invisible chair. It'll love green screens. There I
Okay.
am.
All right, we're done for this session. Thank you all very much for attending, and I
Yeah.
hope
Hey, just before we go, thank you for the references in the chat. I have a bunch of reading to do. Thank you.
and what we should do, what we should do is put all these references on a resource page.
Yeah. Mhm.
On the website. So I'm going to turn the recording off.
Yeah, the ones on the system thinking survey tool, like Jaredot, I
Right.
tried to give you ones that are not paywall.
Okay.
I think one of them is, and but Ryad's at Mississippi State. So, and I probably have all of his
Thank you.
literature.
Mhm. I find as I look back through some of my my papers, and literal papers, because I have things going back to my software engineering days, that I find things that I must have read when I originally put them away that are references that I need now. That hopefully something sunk in that got me here, but it's not enough to remember where I got it from.
Yeah, I've got a load of that as well. All right, we will terminate the session, process the recordings, and publish them. And I ask you to rate the sessions. Go into the individual sessions and rate them after watching the video again or remembering the sessions. They will be useful to us. And thank you all for attending, and hopefully we'll see you tomorrow. Same time, same place.
Joe, are we going to switch channels
Yep.
and do a post-mortem?
Okay. And I will.
Thank you.
I will leave, and the session remains
also.
open. Yep.
Okay.
All right. Give me
Thank you.
15 minutes or so.
All right, great. See you then.
All right. Say again.
Take care, everyone.
10:15 your time, Bruce.
Yeah, quarter after. Mhm.
Okay.